comment brings up some interesting physics related to energy density. Specifically, how is it that a claim like this, that you can get comparable amounts of radioactivity from fossil fuels in the waste as you do with nuclear as a function of the amount of energy that you generate? And it really comes down to the energy density. The energy density for nuclear is just phenomenal. Let me give you an example. When you're doing combustion of fossil fuels, you get about 1 electron volt of energy for each atom that's taking place in the combustion process. When it comes to nuclear, you get about 200 million electron volts for each atom that's undergoing fission. Now, as a result of that, when you have coal, like most Earth, it can have up to or around or more than 3 parts per million of uranium. That's just the average for regular dirt. And so for each atom of coal that's combusting, you've got 3/1 millionths of uranium that's in there. So by the time that you've done, say, 1 million atoms to get 1 million electron volts, you might very well have 3 or more atoms of uranium that's there. And that's only getting you 1 million electron volts, as opposed to one fissioning of uranium getting you 200 million, so 200 times that. And so it is possible to have combustion of fossil fuels produce as much or more radioactivity per terawatt hour of energy that's generated. Now, a lot of that's just going to go up the stack with the exhaust, and the rest of it just goes into the fly ash of the coal. And so it is possible to actually, especially if you have elevated levels of uranium or thorium in the coal, it is possible to have more radioactivity in the waste generated using fossil fuels per terawatt of energy than you get for nuclear. So it's kind of interesting. Nuclear is just so dense. It's just so little material is needed to create so much energy. So hope that helps. Thanks for the comment. Bye.